Soaps and detergent. Now let us understand how soaps and detergent work. Most detergent is oily in nature, and as you know, oil does not dissolve in water. The molecules of soap are sodium or potassium salts of long chain carboxylic acid. So what you need to keep in mind that the soaps are sodium or potassium salts of long chain carboxylic acid. The ionic end of the soap dissolves in water while the carboxylic chain dissolves in the oil. The soap molecule thus forms structure called as the micelle. As seen in the diagram, it is called as the micelle, wherein the ionic end, this is the ionic end which faces towards the outside, and the other end of the molecule is towards the inside of the oil droplet. So if this is the oil droplet, the one end is towards the inside. And this is called as the micelle. This forms an emulsion in water. The soap micelle thus helps in dissolving the dirt in water, and we can wash our clothes clean. So because of this structure, we are able to wash our clothes clean. Now how the structure is formed, we'll be studying about that in the next slide. Soaps are molecules in which the two ends have different properties. One is the hydrophilic, that is, it dissolves in water, while the other end is the hydrophobic end, which dissolves in the hydrocarbon. So we saw in the previous slide that the ends look like there's a circle at one end and there's a zigzag line at the other end. So out of this, the one end is the hydrophobic end. Phobic is fear and hydro is water. So one end fears water and the other end dissolves in hydrocarbons. While soap is at the surface of water, the hydrophobic tail of the soap will not be soluble in water, and the soap will align along the surface of water with the ionic end in the water and the hydrocarbon tail protruding out of water. So as seen in the diagram over here, the blue tip is the hydrophilic tube and the white one is the hydrophobic end. So what happens is inside water, these molecules have unique orientation that keeps the hydrocarbon portion out of the water. So the hydrocarbon portion is going to be outside the water. This is achieved by forming clusters of molecules in the interior of the cluster, and the ionic ends are the surface of the cluster. So since the white portion is the hydrophobic portion, it tries to stay away from water. So how does it try to stay away from the water? So if this is a grease or stain, and all these molecules will start aligning on the grease, they will start forming a circle this way, and all the hydrophobic, since it fears water, it will try to stay away from water and towards the grease. So they form a circle wherein the ends of the hydrophobic are towards the inside and the ionic ends are towards the outside. So that is how they save the tail. So this is the hydrophobic tail and they will be towards the inside, towards the grease, so that they are protected all the time. And this structure which forms the circle structure is called as a micelle. The micellar stays in the solution as a colloid and will not come together to precipitate because of ion-ion repulsion. Thus, the dirt suspended in the micellar is also easily rinsed away. The soap micellar are large enough to scatter light. Hence, a soap solution appears cloudy. And this is how whenever there is a stain on your clothes, the soap solution works so that it removes the stain. Detergents are generally ammonium or sulfonate salts of long chain carboxylic acid and are used when the water is too hard. So the soap solution is sodium or potassium salts of long chain carboxylic acid, but detergents are ammonium or sulfate salts of long chain carboxylic acid, and it is used only when the water is too hard. The charged ends of these compounds do not form insoluble precipitates with the calcium and magnesium ion in hard water. Thus, they remain effective in hard water. When it comes to soap solution, it forms insoluble precipitate, and if you see, whenever you use hard water, the soap solution precipitates in the water and there is very less foam form. But it does not happen in case of detergents. And if you use detergents in hard water, you will see that the foam is present. And hence, detergents are generally used to make shampoos and products for cleaning clothes. Now let us solve a few questions related to what we have learned. The first question, would you be able to check if water is hard by using a detergent? Detergent gives lather with hard and soft water both, while a soap gives lather only with soft water. Thus, it is not possible to check if the water is hard by using a detergent. Next question. People use variety of methods to wash clothes. Usually after adding the soap, they beat the clothes on a stone or beat it with a paddle, scrub it with a brush, or the mixture is agitated in a washing machine. Why is agitation necessary to get clean clothes? Now, a soap solution has two parts, that is hydrophobic and the hydrophilic. The one which fears water and the other one is which loves water. With the help of these, it attaches to the grease or dirt particle and forms a cluster called as the micelle. So we know what micelle is. These micelles remain suspended as a colloid. Now they will be on the clothes no matter what. So to remove these micelli, it is necessary to agitate the clothes. So if you agitate the clothes, the micelli is going to get out and form a lather, and that is how the clothes get clean. And that is why some kind of agitation method is necessary. Now we will be revising the entire chapter with summary. Study of compound of carbon is necessary as it forms the basis of living organisms and the things around us. Carbon has catenation property. Carbon is tetravalent in nature and forms the single, double and triple covalent bonds to combine with elements hydrogen, oxygen, sulfur, nitrogen and chlorine to form various types of compounds. The ability of carbon to form chains gives rise to a homologous series of compounds in which the same functional group is attached to the carbon chain of different lengths. The functional groups such as alcohols, aldehydes, ketones, ether, carboxylic acids give characteristic properties to these compounds. Compounds containing only carbon and hydrogen as their elements are known as hydrocarbons. Carbon compounds are known to exist as linear chains, branch chains, and cyclic rings. Nomenclature is the system of assigning a proper name to a particular organic compound on the basis of certain rules. Carbon and its compounds are some of our major sources of fuel. The action of soap and detergent is based on the presence of both hydrophobic and hydrophilic group in the molecule, and this helps to emulsify the oily dirt and hence its removal.